close proximity of electrical outlets and cords to gas baseboard heaters presents potential safety concerns. Cords and outlets may overheat and melt when located directly above or too close to the heater's hot surface. If the insulation on the cord melts, it can expose bare wires and create a potential fire hazard. Article 300.15 of the National Electrical Code states that in exterior walls, where insulation is required, cables and wiring must be installed in accordance with Article 300. Article 300.20 states that in interior walls where insulation is required, wiring must be rated for the high temperature 40 degrees Celsius or 77 degrees Fahrenheit. Article 210.52 says outlets must be located a minimum of 3 feet above the floor. It is recommended to move the outlets and switch boxes to a minimum of 3 feet above the heater's top surface. Install outlet covers specifically designed to withstand high temperatures. If moving the outlets is not feasible, use heavy-duty extension cords rated for high temperatures and keep them as far away from the heater as possible. Consider installing an interruptible circuit breaker in the circuit feeding the outlets. An interruptible circuit breaker will automatically trip if the circuit overheats, providing added protection. If it is impossible to move the outlets 3 feet above the heater, due to an obstruction, you may need to install a heat-resistant shield between the heater and the outlet to protect the cord from overheating and ensure that the wall behind the outlet is made of a non-combustible material, such as drywall or cement board. The best course of action may depend on the specific installation, and consulting with a qualified electrician for guidance is advisable. Always follow the manufacturer's instructions for installation and use of baseboard heaters. Keep cords and other objects away from the heater's surface. Never overload electrical circuits. Have your electrical system inspected regularly by a qualified electrician. Specifically addressing the scenario presented, the presence of gas baseboard heaters with electrical outlets located only 3 inches above them necessitates a careful evaluation of potential hazards and adherence to relevant electrical codes. The primary concern is the risk of heat-induced damage to the electrical wiring, cords, and outlets, potentially leading to melting, insulation breakdown, and ultimately, fire hazards. Considering the National Electrical Code, Article 300 addresses wiring methods with sections relevant to installations in both exterior and interior walls. It emphasizes proper installation techniques and material selection to ensure electrical safety. In exterior walls, where insulation is commonly required, wiring methods must comply with the guidelines outlined in Article 300 to maintain insulation integrity and prevent overheating. Similarly, in interior walls with insulation, wiring must be rated for the appropriate temperature, typically specified as 40 degrees Celsius 77 degrees Fahrenheit, to withstand the ambient heat generated by the baseboard heaters. It is vital to note that Article 210.52 specifies the placement of outlets in dwelling units, generally requiring them to be located a minimum of 3 feet above the floor. However, this requirement may not directly address the specific scenario of outlets positioned above baseboard heaters. Given the potential safety risks, several recommendations can be considered. Firstly, relocating the existing outlets to a safer distance above the heaters is highly recommended. Ideally, the outlets should be moved to a minimum of 3 feet above the heater's top surface to mitigate the risk of direct heat exposure to the wiring and cords. When relocating the outlets, it's crucial to ensure compliance with other relevant electrical codes, such as spacing requirements and proper grounding techniques. Secondly, if relocation is not feasible due to structural limitations or other constraints, alternative measures can be implemented. One option is to install heat-resistant outlet covers specifically designed to withstand high temperatures, providing an additional layer of protection against heat-induced damage. Another approach involves using heavy-duty extension cords rated for high temperatures, which can minimize the risk of melting or degradation when exposed to heat from the baseboard heaters. These cords should be positioned as far away from the heater as possible to further reduce heat exposure. Thirdly, consider installing an interruptible circuit breaker, also known as an arc fault circuit interrupter, in the circuit feeding the outlets. An interruptible circuit breaker is designed to detect abnormal electrical conditions such as overheating or arcing, and automatically trip the circuit to prevent potential fires or electrical hazards. In situations where a window is located above the baseboard heater, limiting the vertical space available for outlet relocation, additional strategies may be necessary. Installing a heat-resistant shield between the heater and the outlet can provide a barrier against direct heat exposure, protecting the wiring and cords from overheating. Additionally, ensuring that the wall behind the outlet is constructed of non-combustible materials such as drywall or cement board can help minimize the risk of fire spread in the event of a heat-related incident. In any case, it's essential to consult with a qualified electrician who can assess the specific installation conditions, provide tailored recommendations, and ensure compliance with all relevant electrical codes and safety regulations. A professional electrician can evaluate the wiring, outlets, and surrounding materials to determine the most appropriate course of action for mitigating potential hazards and ensuring the safety of the electrical system. It's crucial to emphasize the importance of adhering to manufacturers' instructions for the installation and use of baseboard heaters, as well as implementing basic safety measures such as keeping cords and other objects away from the heater's surface. Overloading electrical circuits should be avoided at all times, and regular inspections of the electrical system by a qualified electrician can help identify potential issues before they escalate into serious hazards. Considering the existing outlets are only 3 inches above the gas baseboard heater, there are multiple potential issues and safety concerns. Firstly, the heat generated by the baseboard heater can potentially damage the outlets, cords, and wiring connected to them. The heat can cause the insulation on the wires to melt or become brittle, which could lead to short circuits, electrical shocks, or even fires. Secondly, the close proximity of the outlets to the heater could also create a fire hazard. If flammable materials come into contact with the heater or the overheated outlets, they could ignite and cause a fire. As for the National Electrical Code, or NEC, several articles may be relevant to this situation. Firstly, Article 110 addresses general requirements for electrical installations, including proper clearances and working spaces around electrical equipment. Article 300 covers wiring methods, including requirements for installing cables and conductors in a safe and secure manner. Article 400 covers flexible cords and cables, including requirements for their use, installation, and protection. Article 424 covers fixed electric space heating equipment, including requirements for the installation of baseboard heaters and their associated wiring. And finally, Article 210 covers branch circuits, including requirements for the location and spacing of outlets in dwelling units. Given the potential safety concerns in the relevant NEC articles, here are some possible solutions. Firstly, relocating the outlets. Moving the outlets to a location that is farther away from the baseboard heater would help to reduce the risk of heat damage and fire. Secondly, using heat-resistant materials. Replacing the existing outlets, cords, and wiring with heat-resistant materials would also help to mitigate the risk of heat damage. Thirdly, installing a heat shield. Installing a heat shield between the baseboard heater and the outlets would provide an additional layer of protection against heat. Fourthly, consulting with a qualified electrician. A qualified electrician can assess the situation and recommend the most appropriate solutions based on the specific circumstances. Regarding the placement of outlets 3 feet above the heater, it is important to consider the specific requirements of the NEC and any local codes or regulations. While a height of 3 feet may be sufficient in some cases, it may not be adequate in others, depending on the design and layout of the room, the type of heater being used, and other factors. As for the window above the heater and the 7-foot rule, this may refer to requirements for the placement of outlets in relation to windows or other openings. Again, it is important to consult the NEC and any local codes or regulations to determine the specific requirements that apply in this situation. In general, it is always best to err on the side of caution and take steps to ensure that electrical outlets are installed in a safe and code-compliant manner. This may involve relocating outlets, using heat-resistant materials, installing heat shields, and consulting with a qualified electrician. Regarding the specific NEC requirements mentioned, Article 300 addresses wiring methods and generally requires that wiring be installed in a neat and workmanlike manner, protected from physical damage, and supported at appropriate intervals. It also specifies requirements for the use of various types of wiring methods, such as conduit, cable, and raceway. The reference to dilating the circuit to 40 degrees Celsius in interior walls likely refers to the ampacity of the conductors. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. When conductors are installed in locations where they are exposed to high temperatures, their ampacity must be dilated to account for the increased heat. This is typically done by multiplying the conductor's ampacity by a dilating factor that is based on the ambient temperature and the type of insulation used on the conductor. For example, if a conductor has an ampacity of 20 amps and is installed in a location where the ambient temperature is 40 degrees Celsius, its ampacity may need to be dilated to 16 amps or less. This would help to ensure that the conductor does not overheat and cause a fire.